Hello guys, welcome back to your channel Learning Point. Today we are going to study differentiation, multiplication and division rule. This is the third part of the chapter multiplication and division rule. In the first two parts I have covered the basic formulas and also some basic examples that we need to know for understanding differentiation part very carefully and thoroughly. So if you haven't still checked those videos guys, I would suggest go check out those videos. I am giving the link of those lectures in the description. So go and check it out and then once again you can turn back to this particular video so everything will be very clearly understood to you guys. Let us continue with our today's lecture multiplication rule and division rule. Let's get started. Come on. Multiplication rule in derivatives has got one more name called as UV rule. Division rule has got one more name called as U by V or U upon V rule. So let us start with the first, which is the multiplication rule. If y is equal to u into v, where u and v are any two kinds of functions of x, they can be algebraic and exponential, or they can be exponential and logarithmic, or they can be logarithmic and exponential. Any two kinds of different functions, when they are multiplied, then we have to always apply the multiplication rule. Okay, I'll give you some examples. Let us consider. First of all, let us see what is the formula for the u into v rule or multiplication rule. The rule goes like this. If y is equal to u into v, then dy by dx is v du by dx plus u into dv by dx. It's very easy to remember guys. You can see over here. In the first term I am taking the derivative of u. So I have left this v element as it is over here. In the second term I am taking the derivative of v. So I am leaving this u element as it is. So I can say y is equal to u into v. Then derivative of y dy by dx is equal to derivative of u multiplied by v, which we say that's v du by dx, plus derivative of v multiplied by u, which we say is u dv by dx. So in short, the formula is v du by dx plus u dv by dx. In case which we come across that there are three terms multiplied with each other. If I have y is equal to u into v into w, then the same formula can be extended for three terms. I can say dy by dx is equal to, first I take derivative of u, then in such a case v and w will be left as it is, plus when we take derivative of v, u into w will be left as it is, and when we take derivative of w, dw by dx, we will say u into v, over there it is left as it is. Okay, so the answer is vw du by dx plus uw dv by dx plus uv dw by dx. Yes, let's see some examples for this and then we will go to our second rule, which is the division rule. Example 1. I'll start with a very easy example guys. If I come across a question which is y is equal to e raised to x into x raised to 4. So you can clearly make out from this is an algebraic term and this over here is exponential term. I had told you in the beginning I will have two different terms or two different functions which are multiplied with each other. Then I have to apply u into v rule. So when I want to apply the rule, I have to first of all say over here differentiating with respect to x. So derivative of y is dy by dx. Now as we already know the rule, I have to first take the derivative of u. So I will take d by dx of u, that is e raised to x, and this x raised to 4 will be left as it is, plus in the second case I have to take the derivative of v, which is x raised to 4. So I will leave this e raised to x as it is. So as I had told you, the formula is v into derivative of u plus u into derivative of v. So then when I apply the formula, x raised to 4 is outside the derivative sign, so nothing will happen to it. It will just come down as it is. E raised to x, derivative is e raised to x, plus e raised to x is again outside the derivative sign. It will come down as it is without any change. But x raised to 4, we will apply the formula for derivative x raised to n. And the formula for x raised to n is n into x raised to n minus 1. So the answer is 4 into x raised to 4 minus 1, which is 4x cube. And in order to give the simplified answer, I can take out e raised to x common from these both terms, as well as I can take out x cube common from these both terms. So if I take out the common elements, I get the answer as e raised to x into x raised to 3. I will be still left with one x element over here, and e raised to x is outside, x raised to 3 is outside, so I am just left with value 4. That finishes your value for dy by dx. Isn't it very simple, guys? Let me take one more example for you. Example number 2. Suppose if I have a question which is a combination of x raised to n, a raised to x. X raised to n is algebraic. 5 raised to x is similar to a raised to x, which is an exponential function. Let us understand once again how we have to differentiate this. So as you know, we have to write over here differentiating with respect to x, derivative of y, dy by dx. So this is v into derivative of u, 5 raised to x into derivative of x raised to 4 by 7 plus u into derivative of v, x raised to 4 by 7 into derivative of 5 raised to x. As you know, this 5 raised to x is outside derivative. There won't be any change. It will come down as it is. X raised to 4 by 7 is similar to x raised to n. So when I know the formula for x raised to n, which is n into x raised to n minus 1, I can easily apply the formula that becomes 4 by 7 x raised to 4 by 7 minus 1 plus leave this x raised to 4 by 7 as it is because it is outside derivative, as you know. and then 5 raised to x over here is similar to a raised to x. The answer for a raised to x is a raised to x into log a. So I can say that derivative of 5 raised to x will be 5 raised to x into log 5. Now in order to simplify, I can take out 5 raised to x common from these both terms. So when I take out 5 raised to x common, I get the answer, 5 raised to x. This 4 by 7 will be there as it is. X raised to 4 by 7 minus 1 will become minus 3 by 7, plus we leave this x raised to 4 by 7 over here and log 5. So that finishes your answer, dy by dx. So I get this as my answer. Okay guys. Now let us take an example with the help of a logarithmic function. Example 3. One last sum. If I have y is equal to log x into 3 raised to x into x square minus 2x. So if I have this kind of a question, you can see there are three terms, u, v and w. So as per our formula for UVW, it is VW derivative of u plus UW derivative of v plus UV derivative of w. Now looking at the formula, you may feel it's a very large formula, but believe me, it's very easy to remember. Let us understand how you can remember this. What you can do is take the derivative of u, write v and w as it is. When we are taking derivative of v, write u and v as it is. And when we are taking derivative of w, we will write the last remaining two terms u and v as it is. Is that very easy, guys? So let us see how we can apply this particular formula over here. We have to say differentiate with respect to x, derivative of y, that is dy by dx. As I told you, as it is same just now, when we are taking the derivative of u, v and w will be copied down. So 3 raised to x into x square minus 2x into derivative of log x, plus I want to take derivative of v, so u and w will be copied down, log x into x square minus 2x into the derivative of 3 raised to x. Then I want to take the derivative of w, so u and v will be copied down as it is. So log x into 3 raised to x multiplied by derivative of x square minus 2x. So now let us apply the formulas. This 3 raised to x will be as it is because it is outside the derivative sign. X square minus 2x, as you know, again it will be left outside. Derivative of log x, you got it right, 1 upon x, plus log x and x square minus 2x will be copied down as it is. derivative of 3 raised to x, which is same as a raised to x as we saw just now. The answer was a raised to x into log a. So a is 3 in this case, so I will get 3 raised to x into log 3 plus log x, and 3 raised to x will be copied down as it is. Inside the bracket, we will apply the formula for x raised to n. X square x raised to n, the answer will be 2 into x raised to 2 minus 1. So I get the answer as 2x minus derivative of x is always 1. So I get 2 into 1, which is 2. So in order to simplify, what I can do is I can take out 3 raised to x common from all the 3 terms over here, and in the first term I will take out x common so that the denominator can be cancelled off, and in the last term I will take out this 2 common because I have 2x minus 2, so I can simplify by writing it like this. First of all, 3 raised to x, which is common for all the terms. Then I will write over here x minus 2 multiplied by x and upon x plus, these all terms will be as it is, log x into x square minus 2x into log 3 plus this 3 raised to x has been taken outside, so I will write 2 common, x minus 1 and log x. We can cancel off the x values over here, and hence our final answer dy by dx 3 raised to x, and in the bracket x minus 2 plus log x into x square minus 2x into log 3 plus log x. So that is all about your multiplication rule, guys. Still, if you have got any doubts or questions in your mind, you can always put a mail to me. I will definitely send the solution over the email. Now let us get back to our next rule, which is the division rule. Let's check out rule number 2. Division. If y is equal to u upon v, as you already know that u and v are any two differentiable functions of x, logarithmic and exponential, or exponential and algebraic, or in fact algebraic and exponential, any of the combinations is possible. So I will get over here derivative of y dy by dx. As we saw in the multiplication rule, I will take the derivative of u first multiplied by v, take the derivative of u, in fact v now, and multiplied by u. In case of multiplication rule, we have to add. In case of division rule, we have to subtract. One more change over here, it will be divided by the denominator square, which is divided by v square. So the rule says it is v derivative of u minus u derivative of v upon v square. Come on, let us understand how to apply this with the help of few examples again. Example 1. We'll start with a very easy one, guys. If I have y is equal to x square plus 1 divided by log x. Then I will differentiate this with respect to x. Derivative of y, as you know, it is dy by dx. And when we are solving, I will assume that this is u and this is v. You already know the formulas. I have to take, it is v into derivative of u minus u into derivative of v. So let us substitute log x into derivative of x square plus 1 minus x square plus 1 into derivative of log x and whole upon v square. So I will get over here log x the whole square. Then when we simplify, this log x is outside the derivative, and as you know from multiplication rule, element outside the derivative is copied down as it is. So log x is as it is. X square, the derivative of x square is 2x because it is x raised to n, plus 1. 1 is a constant. As you know, derivative of a constant is always 0. So I get 2x plus 0, which is just 2x. For the next term, minus x square plus 1, it is outside the derivative sign. So just we leave it as it is. Derivative of log x is 1 upon x. And once again, whole divided by log x the whole square. So what do we get? I can take LCM over here in the numerator. So it will become 2x into x, 2x square into log x minus x square plus 1 inside the bracket whole upon x. And the denominator can be just written aside over here like this, 1 upon log x the whole square. Finally, I can combine both the terms by writing it 2x square log x minus x square plus 1 and whole upon x into log x the whole square. This is equal to dy by dx. Isn't that very simple, guys? Who says derivative is difficult? It is a very easy topic, guys. Very easy topic. If you know all the formulas, you know all the rules, you can get full in all the sums of this chapter. Come on, let us take one more example for this. For u upon v rule, example 2. I'll take an example which is combination of the multiplication and the division rule over here, so that you understand how we have to apply the question in this kind of a question, formula in this kind of a question. In fact, I'm sorry, y is equal to x square e raised to x divided by 2x plus 1. So let us see, we have to write over here differentiate with respect to x, derivative of y dy by dx is equal to, as we know the formula, I have to consider the numerator as u and the denominator as v. So in such a case, let us substitute them in their respective places. V into derivative of u, 2x plus 1 into derivative of x square into e raised to x plus x square into e raised to x multiplied by the derivative of 2x plus 1 and whole divided by v square, which is already 2x plus 1 the whole square. Remember guys, you don't need to expand this denominator with the help of a plus b the whole square or a minus b the whole square or anything. It will be just kept as it is till the end of the answer without doing anything to that. Okay. So as we know, this 2x plus 1 is outside the derivative, so we will leave it as it is as 2x plus 1. X square into e raised to x. Yes, you can make out from here that this is an algebraic term and this is an exponential term. So I am having a product of algebraic and exponential term. So I consider this as u and this as v. So here it becomes u into v rule, multiplication rule. So inside u by v rule, inside division rule, we have come across a stage where we have to apply the multiplication rule. So let us see. I will get over here. Let us once again recollect our formula first. The formula for the u into v rule was v into du by dx plus u into dv by dx. So substitute over here guys. V is e raised to x, u is x square. So when I substitute, I get e raised to x into derivative of x square plus x square into derivative of e raised to x. I have by mistakenly taken plus over here. I'm sorry for that. It has to be subtraction. X square into e raised to x is as it is, and derivative of 2x plus 1 we will write it as it is for now, and in the next step we will take the derivative of all the terms together divided by v square, which is 2x plus 1 the whole square. Now this 2x plus 1 is outside the derivative or outside the bracket, so leave it. Inside the bracket, e raised to x is as it is. Derivative of x square is 2x plus x square is outside the derivative, so we leave it as it is. E raised to x is an exponential term whose derivative is e raised to x itself. So I get e raised to x multiplied by x square for this term. Once again, minus x square e raised to x is outside derivative, so leave it. Derivative of 2x, 2 is the coefficient, so 2 won't change anyway. Derivative of x is 1, so I get 2 into 1, which is 2. And derivative of 1, which is a constant, is 0. So I will be just getting the value as 2 over here. Divided by 2x plus 1 the whole square. So what I can do over here is now inside this bracket I can see e raised to x as a common value as well as x as a common value for these both terms. So when I take out the common value outside, 2x plus 1 e raised to x into x. So the bracket over here will have 2 plus x minus x square e raised to x into 2 and whole divided by v square. So that should give us 2x plus 1 the whole square. Once again guys, you can see this is our entire first term, and in the entire second term e raised to x is common, so I have to take that common element once again, as well as x is common for these both terms too, so I can take out x also common outside. So finally my answer should come out to be like this: e raised to x into x inside the bracket First term 2x plus 1, second term 2 plus x minus, I have taken out x as a common value, so I will be left with x and also with this 2, and whole divided by v square. So this divided by 2x plus 1 will be as it is, the whole square of course. Yes, now we have to simplify the bracket and write the answer in the most simplified format. So this x into e raised to x will be as it is. When we open the bracket, 2x into 2, 4x, it will become 2x plus into x, so it will be plus 2x square. 1 into 2, that is plus 2, and 1 into x is plus x minus 2x, and whole divided by 2x plus 1, the whole square. Once again, x into e raised to x is as it is, and now 4x plus x is 5x. 5x minus 2x is 3x. So I'll write the answer in the proper order: 2x square plus 3x plus 2, and whole upon v square, which is again 2x plus 1, the whole square. This is my final value for dy by dx. Gosh, I'm sorry. So guys, I hope you have liked the video. You have understood all the points very clearly. Please like and subscribe our channel and press the bell icon so that you don't miss out any updates. Thanks a lot. Good day.